Hey everybody, Mr. Chu here. I'm going to take you through Investigation 8.7, which is surface area. Previously, we've looked at just area of two-dimensional shapes like circles, regular polygons, triangles, parallelograms. But what if we were looking at three-dimensional figures? And today we're going to look at prisms, pyramids, cylinders, and cones. Now, some of those things you might be familiar with, others maybe not. But we'll start out with the most simple idea of surface area, which is that we're going to be finding the area of each of the sides of a three-dimensional figure. I'm going to follow along on your investigation, so I'm on page 1. For prisms and pyramids, there's a couple new vocabulary terms. The bases are going to be typically regular polygons, or in our case, they're going to be regular polygons. Okay. Notice that this is a prism. The base here is a hexagon. The base of this pyramid is a pentagon. The sides, or the lateral faces of this prism, are rectangles. Notice that they'd all be the same length and width, or base and height. And for this pyramid, the lateral faces are triangles. That's going to be very important in finding the surface area. Here's a couple cool things that you might see in the everyday world. This is in Paris. We've got buildings all over our fine city, and some pyramids and cylinders and such, different architectural. To find the surface area of a prism, there's actually some very easy steps. This first example is a rectangular prism. Notice it does have the base dimension, the height dimension. There's also this third dimension here. Okay. The idea with this is we're going to find the area of each face and add them all together. Okay, so the area of this front face is 2 times 4. Notice that it's on the front side. There's also a back side. Then we'll look at this base here, or this face here. This is 2 times 5, and there's a second face in the back as well. Now the bottom part of this is 4 by 5, as is the top. So you should wind up getting 2 times 2 times 4, because there's 2 faces, 2 times 2 times 5, because there's 2 faces, and 2 times 4 times 5, because there's 2 faces. When you multiply and add together, you should get 76 meters squared. Notice that our units are again squared. This is still area. Next, the surface area of a cylinder. This one's a little bit more tricky, but I'm going to allude to a problem that we looked at in last chapter that had to do with a label on a can. Okay. Now the base here is a circle. This one is the same. Okay, so to find the area of these circles, recall that it's going to be pi times the radius squared, but since there's 2 of them, it's going to be 2 pi r squared. We're going to add that to the surface area of the side of this cylinder. Now, if you recall, or if you need to, you can take a sheet of paper, roll it up so that it's cylindrical. If you notice that the circumference, or the distance around the circle, is going to be the same thing as the length of the rectangle. Now this height of this rectangle is 12. Okay, so if we set that up, there's a lot going on here. But there's 2 circles, so it's 2 pi r squared plus the circumference times the height. Okay, circumference is acting as the same thing as the base of your rectangle if you unfolded the cylinder. Once you plug in your values and evaluate, you should get 170 pi inches squared. So we're going to step into something a little bit more tricky. We're going to talk about pyramids. Okay. Now pyramids, again, they have a polygon base and all the sides, or the faces are going to be triangles. So we have something that looks a little like this. And if we break it up into different pieces, we'll see that we have different number of triangles and some regular polygon base. For the purpose of this section, we'll be using B for the side of the polygon. We'll still use little a as the apothem, and then the L here, this is going to be called the slanted height. Okay, we use the slanted height instead of the vertical height of the pyramid because we're looking at each individual triangle. Okay, and that height has to be from the highest point to the base at a 90-degree angle. Or, sorry, the vertex of the triangle to the base at a 90-degree angle. Going through the steps, we have to first figure out the area of each lateral face. Again, the lateral faces are going to be your triangles. Now, if we're looking at just one of them, the area of a triangle, as you should know by now, is 1/2 base times height. But again, we're using L as our height, so it's going to be 1/2 base times L. Step 2, what is the total surface area, lateral surface area, given a polygon with n number of sides? So it's just going to be n times the total number, n times the area of this triangle. So we get n times 1/2 base times L. What's the area of the base for any regular n polygon? Well, that's just finding the area of a regular polygon, which you should know as 1/2 apothem times base, in this case, times the number of sides of the polygon. Now step 4, we're going to take steps 2 and 3, combine them together, because the idea with the surface area is we want to find the area of this base, add it to the area of each of these faces. Okay, so we get n times 1/2 BL, which was step 2, plus 1/2 ABN. But notice that both of these have 1/2 in common, and they also have B in common, and they also have N in common, so we can factor them out to get a much more simple formula here. 1/2 BN times the quantity L plus A. For step 5, we can actually simplify that a little bit more because we know that B times N, okay, that's going to be the same thing as perimeter. Again, that's going to be the same thing as the perimeter. B times N, we can substitute in P for the perimeter to get an even more simple formula. So that's 1/2 times the perimeter times L plus A. Okay, we'll get some practice with this in just a moment. But let's go into finding the surface area of a cone. This one's actually really tricky. Okay, now a cone, if we cut it up, notice that all the sides are smooth. There's no like faces like a pyramid. But if we cut up this top piece of the cone and fan it out like the book has it here, we've got all these different sections of triangles that you can cut up and piece together to get a rectangle. And that's going to be very important in finding the area of a cone, surface area of a cone. So we have a base of a circle. Now the area of that base is going to be pi times the radius squared. The lateral surface area in terms of L and R, well, in terms of L and R here, what portion of the circle is a sector, and what is the area of the sector? Let's take a look here first. Here's our sector, okay, and if we break it up and flip the little triangles upside down, we wind up getting a nice rectangle. And the area of this rectangle, as we know, is base times height, which would be pi r times L. Okay, pi r times L, that's what we have here. For step 3, we'll combine steps 1 and 2. So pi r squared plus pi lr, and we can factor out pi r to get a very nice and simple formula. So we have pi times the radius times the quantity radius plus L, okay, where L is going to be this slant right here. Looking at a problem real quick here, we've got the total surface area of a cone. We have the radius of this going to be 5 centimeters. The slant here is going to be 10 centimeters. I want you to go ahead and try this and check your answers with your neighbor, and we'll pick this up later on tomorrow. Thank you. Have a nice day.